Question 4, we obviously need to draw out a diagram as we go. So a vertical cliff is 73.5 metres high. Two stones A and B are projected simultaneously. Stone A is projected horizontally, so that's A, with speed 28 metres per second. Stone B is projected from the bottom of the cliff with speed 35 at an angle alpha above the horizontal. The stones move freely under gravity in the same vertical plane and collide somewhere here collide in midair. By considering the horizontal motion of each stone, prove that this must be the case. So with their x distance must be the same for both. So for stone A, the x distance, x is v times t. So it's just going to be 28t. For stone B, down here, we've got the x distance must be v, 35, cos alpha times t. X distances are the same, therefore I can say that 28t equals 35 cos alpha t. T will cancel and I get cos alpha is 28 over 35, so cos alpha divided by 7 is 4 over 5. Part B, find the time which elapses between the instance when the stones are projected and the instance when they collide. Well, they must now be at the same y distance, so we now have to consider the y thing. So for stone B, we'll start with B first. Y is equal to v sine alpha t minus a half gt squared. If I stick in some values, I get v is 35. Sine alpha, well, if I know that cos alpha is 4/5, sine alpha must be 3/5. So I get 35 times 3/5 t minus a half gt squared. Half 9.8 t squared. If I now consider A, then A's height above the ground will be 73.5. So 73.5 minus whatever it's dropping by. Okay, so it's going to be v sine alpha, so it's not nothing there, but just a half 9.8 t squared. So minus a half 9.8 t squared, and that will be its y distance above the ground. If I stick the two things equal to each other, then we get 73.5 minus a half 9.8 t squared equals 35 over 5 is 7 times 3, so 21t minus a half 9.8 t squared. They cancel out, leaving me with t is equal to 73.5 over 21, which is t equals 3.5 seconds. There we go.